This example is for finding a zero on the calculator of a quadratic. We're going to do number 4 in the textbook. When a pumpkin chunker launches a pumpkin, the goal is long distance, not necessarily height. So suppose the relationship between horizontal distance and time is given by the function rule d equals 70t, and then the height is given by h is equal 20 plus 50t minus 16t squared. How long will the pumpkin be in the air? So we need to think about how long the pumpkin is actually going to be in the air and then what that means. So 20 is the initial height of the pumpkin in the launching contraption. 50 is its velocity, and then this negative 16t squared is gravity. So 20 is the initial height. 50 is the velocity. And negative 16t squared is gravity. That's really important to remember. And when we're thinking about this and how long the pumpkin is going to be in the air, that means that that equation, the height is equal to 0. So we have 0 equals 20 plus 50t minus 16t squared. And then in the calculator, we put that in the y equals, and then we look at the table. Right now my table is at 13 seconds. That's definitely not going to work. So I'm going to make my table start at 0. Come back to the table, and then somewhere in between 3 and 4 seconds it hits the ground, because at 3 seconds it's still 26 feet in the air, and at 4 seconds it says negative 36. So that means this is below the ground, which is not going to happen. So somewhere in between 3 and 4 it hits the ground. So we have to do second table set, start the table at 3, and count by tenths to kind of zoom in on where we're looking for when it hits the ground. At 3.4 seconds, it's 5.04 feet. And then at 3.5 seconds, it's definitely impacted because this negative 1 means it's 1 foot below the ground. So we do second table set and start at 3.4 and then count by hundredths of a foot. And then we look at the table, and right here at 3.48, 0.223 or 0.2336 feet above the ground is just like 3 inches above the ground. So we'll say that right there is when it hits the ground at 3.48 seconds. So it hits the ground or is in the air for 3.48 seconds. And then how far will the pumpkin travel from the chunker by the time it hits the ground? That is a horizontal distance question. So what we need to do is substitute in the 3.48 into this equation right here, the horizontal distance, because the distance is equal to 70 times the amount of time the ball or the pumpkin was in the air. So we can do that calculation in our calculator. Quit out, do 70 times 3.48, and we come up that the pumpkin is 243.6 feet away from the chunker. So we'll write that in a nice sentence. Okay, so that is how you find the zero and then how you would calculate horizontal travel distance.